Welcome back everyone. Today we're going to be doing experiment 6, acid-base titration. An acid-base titration is a titration where we use a base, titrate it into an acid to determine the molar concentration of an acid in an unknown solution. Today we're going to be using sodium hydroxide in our burette to titrate first hydrochloric acid, a standard, then an unknown acid, and finally to determine how much aspirin or acetyl salicylic acid is in a certain mass of aspirin. We will be using phenolphthalein as our indicator. This indicator will tell us exactly when we're at a pH of 7. So for a monoprotic acid, that is an acid with one hydrogen, and for a base such as sodium hydroxide, when those two molecules have equaled each other, we will be at a pH of 7, which is neutral. At that point, our indicator will turn pink, allowing us to know we have reached the end point of our titration. So first, we're going to standardize our sodium hydroxide titration solution using a standard hydrochloric acid. The hydrochloric acid, it has a molar concentration that we know already, but the sodium hydroxide has not been standardized. That means we don't know exactly the molar concentration of the sodium hydroxide solution. We may have a rough estimate, but we need to know exactly how much it is in order to have an accurate titration. But before we begin the experiment, we need to discuss lab safety first. We need to make sure that we're always safe in the lab, so that way we don't injure ourselves or injure someone else. To do so, we need to make sure that any long hair is tied back to avoid getting into any of the chemicals. We need to be wearing our goggles, we need to be wearing gloves, we need to be wearing a lab coat that's buttoned up with no skin exposed below the waist. So that includes wearing long pants that cover your ankles and having closed-toed shoes. Please also remember not to wear leggings in the lab, as chemicals that are spilled will soak in more rapidly and contact your skin. So try and wear looser clothing that covers all of the skin below your waist. So to begin the standardization part of this lab, we're first going to want to rinse our burette using our sodium hydroxide solution. So I have poured some sodium hydroxide solution into a beaker, and we can remove the burette from the burette stand, and then either using a funnel or using the beaker itself, just pour a small amount into the burette, maybe about 5 milliliters. And then after adding your sodium hydroxide, slowly tilt and rock the burette back and forth, and then spin it to completely cover the insides of the burette with our sodium hydroxide solution. And then let the sodium hydroxide solution that you used to rinse and drop it into your waste beaker. You want to do that at least 2 or 3 times to make sure that there's no water, residuals left over in your burette, and that it is ready for your titration. So we can then put our burette back into our stand and then add our sodium hydroxide solution to the burette until it's near. So we'll stop there, and then we need to take the initial reading of our burette. If you need to, you can either bring the burette down a little lower, but you want to make sure your eyes are level with the gradations, so that way you can measure where the bottom of the little bubble or meniscus touches the gradation lines. So this one is at a little over 3 milliliters, so let's call it 3.02 milliliters. We'll need to write that down for future reference. Next, we need to put 25 milliliters of our hydrochloric acid standard solution into an Erlenmeyer flask that we'll be using for the titration. You can either use a graduated cylinder, or you can use a volumetric pipette like this. So to use the volumetric pipette, we will use a pipetter on the top, and we will put it into our Erlenmeyer flask or whatever flask that contains your standard hydrochloric acid solution, and then slowly roll the thumb wheel in order to draw up the solution into the pipette. When it's just above the line, we can remove the pipetter and stick our finger over the top, which will allow us to slowly drain it until we have exactly 25 milliliters in our pipette. So now that we have it at 25 milliliters, we can then dispense this into our Erlenmeyer flask. The Erlenmeyer flask needs to be clean, but it doesn't necessarily need to be completely dry. because this is a mole-to-mole type of reaction, so the concentration doesn't matter as much. Now that we have our hydrochloric acid solution in our Erlenmeyer flask, we can add a couple drops of our indicator. And then begin the titration itself. So to begin, you can start by adding drops more quickly, but as your solution becomes more and more pink, and the pink lasts longer, you want to try and slow down the amount that you're adding so that way you can get the endpoint exactly without overshooting it. As you add a drop, sometimes you'll notice when you get close to the endpoint that the pink color is more persistent and it takes more stirring to go back to clear. So at this point you want to take your time and go very slowly because you're very close to the endpoint. We need to see that the color of the this pink color persists for about a minute after we reach the endpoint to be sure that we're there. Sometimes, even after it becomes pink like this, as it mixes in the solution, it can go back to clear, and we'll need to add one more drop in order to get it to pink. So when you finish your titration, you want a lighter pink color like this, not a dark pink color, because a dark pink color says that you've overshot it. So as long as this very light pink color stays persistent over a minute or so, you'll know that you've reached the end point. If you go a little bit too far, then you'll have the darker pink color like this, which is not exactly what we want. So now that we have reached the end point of our titration, we can record the amount of solution we've added by determining where the volume of water is, or of solution is in the burette, which is at 24.1. We can then write that down and subtract the starting volume from the final volume to determine our total volume added to our Erlenmeyer flask. So after you have performed this titration for the standardization once, you need to do it one more time and make sure that the two results are no less than 0.2 milliliters apart. You can then average the results together, and we'll show you the math next about how to determine your concentration of sodium hydroxide in your titration solution. If the volume added to your flask in the standardization titration is more than 0.2 milliliters apart, you should repeat it for a third time and try and be a little more careful this time to try and hit that endpoint just right so that the two observations match. So now that we've done the standardization titration, let's look at the equations that we'll need to determine the molar concentration of our sodium hydroxide solution. Our ending volume was 21.7 milliliters on the burette. Our starting volume was 1.3 milliliters. That gives us a total volume used of 20.4 milliliters. We'll need to convert that to liters by dividing by 1,000, which will give us 0.0204 liters of sodium hydroxide solution. We can then begin with what we know, and we know that our hydrochloric acid solution is 0.1 molar because it has already been standardized for us. We can take 0.1 molar, which is 0.1 moles of hydrochloric acid per liter, and multiply it by the volume that we used, which is 0.025 liters, which is 25 milliliters. This is equal to 0.0025 moles of hydrochloric acid. We know that this reaction has a 1-to-1 stoichiometry. That means for every 1 molecule of sodium hydroxide, it neutralizes 1 molecule of hydrochloric acid. So we multiply it by that stoichiometry, or 1 moles of sodium hydroxide over 1 moles of hydrochloric acid, to get 0.0025 moles of sodium hydroxide used. We can then multiply it by that number by our volume used from the burette to get our concentration of sodium hydroxide, which in this case is 0.12 molar sodium hydroxide. Next, we're going to be determining the molar mass of an unknown acid. We have an unknown acid here, and we're going to be weighing out 0.1 grams, or 1/10 of a gram, of this powder into a weigh boat using an analytical balance. So first, we will turn on the balance, ensure that it's level. If you need help adjusting the balance, please ask your TA. And then we will add our weigh boat to the balance first. Once the reading has stabilized, we can hit tare, which will return the balance to 0, which will then allow us to weigh out 0.1 grams of our unknown acid. Once we have weighed out our mass of unknown acid, we can then record it on a piece of paper to be used later and remove it from the balance. We can then add it to a clean Erlenmeyer flask. So after we have added our unknown acid to an Erlenmeyer flask, we then need to add 25 milliliters of distilled water to our Erlenmeyer flask as well. Once again, you'll need to rinse your volumetric pipette if you're using one, or just use a graduated cylinder. After we have added our distilled water to our Erlenmeyer flask, we want to make sure that all of the solid is dissolved into the water before we begin the titration, or else our results may not be correct. And also add a couple of drops of our indicator to the Erlenmeyer flask as well. So after we have dissolved all of the solid unknown acid into our Erlenmeyer flask, we can then begin our titration using our burette. Remember to first determine what your starting volume is, which in this case is 2.6 milliliters. And you're looking for that same pink color again that we saw during our standardization titrations. So we can begin by slowly adding some of our sodium hydroxide solution to our flask. When you have finished your titration, it should be a light pink color like this. That should be persistent for about a minute. If it returns to clear within a minute, add just one more drop and then you should have reached your end point. So now that we have finished our titration, we can record the final volume on our burette and write it down, and then subtract your initial volume to determine how much volume you have added to your Erlenmeyer flask. You need to do this 2 times for your unknown acid using 2 different samples. That way we can show you later how to average those results to determine the molar mass of your unknown acid. You may not be able to determine the exact molecular formula of the acid, but the lab only requires that you determine the molar mass. So next we're going to be determining how much salicylic acid is in some aspirin. We don't have aspirin tablets, we have a mixture of aspirin, so we're going to weigh out 100 milligrams of aspirin into our weigh boat on our analytical scale. So once again, we'll put our weigh boat in the balance, wait for the numbers to stabilize, and then hit tare. Once it shows all zeros, we can then remove the weigh boat from the balance and add our aspirin mixture to the weigh boat. So once we have weighed out the mass that we need, in this case I'm going to be using 100 milligrams, we can then remove the weigh boat from the balance and add it to our Erlenmeyer flask. We then need to add 100 milliliters of distilled water to our Erlenmeyer flask in order to do the reaction with the titration. Once you have added your 100 milliliters of water to your Erlenmeyer flask, you need to make sure that all of the aspirin is dissolved into the water before you begin the titration. Now that we have dissolved the aspirin mixture in water in our Erlenmeyer flask, we can then add a couple drops of our indicator again, and then begin the titration. We first need to record our starting volume on the burette, 12.8 in this case. After doing so, we can begin to add our sodium hydroxide solution to our Erlenmeyer flask dropwise. So after adding your salicylic acid, your aspirin mixture to the flask and your distilled water, you need to shake it around until it dissolves. You may see a little bit of small particulates inside of the solution. These are likely the binder that are used to make pills into a pill shape that hold their form. So it doesn't all need to dissolve, but we want to try and get as much of the salicylic acid that's in that mixture into our solution before we start the titration. So after stirring the flask, we can then add a couple drops of our indicator. And then we can begin our titration by first writing down the starting volume on your burette, 15.9, and then slowly adding dropwise your sodium hydroxide solution to your burette while stirring. So once we have a pink color that is persistent, and no matter how much you mix it, it continues to stay pink and doesn't go back to clear, we will know that we have reached the end point and that we have deprotonated all of the salicylic acid that was in that aspirin mixture. So once we're at that point, we can then record our final volume on the burette, which is 18.8, and we can subtract that from our starting volume to determine how much sodium hydroxide we added to our Erlenmeyer flask. So that concludes Experiment 6, Acid-Base Titration. If you have any further questions, please ask your TA for help, and please report any injuries or accidents or broken glassware to your TA as well. When you're finished, please dispose of all of your chemicals as directed by your TA, and then throw away your gloves and wash your hands with soap and water. Thanks for your attention, and I'll see you in the next video.